We cannot say with certainty when life as we know it first emerged in the universe, but the answer is closely tied to the moment water first appeared. New simulations suggest that the first generation of stars played a crucial role in forming water as early as 100 million to 200 million years after the Big Bang, pushing back previous estimates by more than 500 million years. Researchers were surprised to find that water could have formed so early, even before the birth of the first galaxies. If some of this initial water reservoir survived the intense conditions of early galaxy formation, it could have been absorbed by newly forming planets, potentially leading to habitable, water-rich worlds just a few hundred million years after the Big Bang. Observations from the Atacama Large Millimeter bar Submillimeter Array, ALMA, in Chile, had previously detected water around 780 million years after the Big Bang, a time when the universe contained primarily hydrogen, helium, and small amounts of lithium. These elements gave rise to the first generation of stars, known as population 3 stars, which were massive, often dozens or even hundreds of times the mass of the Sun, and had short lifespans, ending in powerful supernova explosions. These early stars played a key role in enriching the universe with heavier elements like oxygen, which were produced through nuclear reactions within the stars and released into space when they exploded. To determine when water first formed, scientists conducted numerical simulations of 2 first-generation stars, one with 13 times the mass of the Sun and another with 200 times the mass. The smaller star lived for 12.2 million years before dying in a supernova, ejecting about 0.051 solar masses of oxygen, equivalent to nearly 17,000 Earth masses, into space. The larger star burned through its fuel in just 2.6 million years before exploding and dispersing 55 solar masses of oxygen, more than 18 million Earth masses. The simulations revealed that shockwaves from these supernovae caused turbulent density fluctuations, which led to the formation of dense clumps of gas. These clumps, enriched with metals like oxygen, were likely primary sites for water formation in the early universe. Water molecules in these denser regions were shielded from being destroyed by intense radiation from nearby stars. However, the simulations considered only single stars forming in each clump, whereas theoretical models suggest that multiple star systems were more common. If multiple stars formed nearby, there would have been both more dense, water-enriched clumps and more radiation, which could have influenced water formation. Despite this complexity, researchers still believe that water could have persisted under these conditions. Follow-up simulations suggest that these water-rich clumps were also promising environments for habitable planets to form. Whether water from these early clumps survived through billions of years of cosmic evolution remains uncertain. One theory proposes that comets delivered water to Earth, but such icy bodies from the early universe may not have endured the harsh conditions of the epoch of ionization, which occurred about 400,000 years after the Big Bang, and was marked by intense ultraviolet radiation from the first stars and galaxies. Nevertheless, researchers have not ruled out the possibility that some of Earth's water could have a primordial origin. If water-rich planets existed in the early universe, they would emit faint signals that might be detectable in the coming decade by ALMA or the Square Kilometre Array in Australia and South Africa. Detecting such emissions would be a major breakthrough, potentially shifting the timeline for the emergence of life to within just a few hundred million years after the Big Bang. Did you know that over 95% of our viewers aren't subscribed to the channel? We totally get it. Life gets busy, and sometimes it's easy to forget. But here's the thing. Subscribing is completely free, and it really helps us keep creating the content you enjoy. So, why not hit that subscribe button and join our community? It only takes a second, but it makes a world of difference to us. Thank you for your support.